Working with the slope of a line. So the slope describes the steepness of a line, and the symbol for slope is a lowercase m. And what it's made up of is the vertical change over our horizontal change, or the y's over the x's. So when you're given a picture and you want to find the slope of that line, you can count from one point to the next point to find the x values and the y values. A slope of a line. When we're looking for a slope of a line given a picture, the slope describes the steepness of that line. The abbreviation for slope is a lowercase m, and it's made up of our vertical change over our horizontal change, and that is in the line. So it's the y's over the x's. So when I'm looking at the picture of a line, I can find the slope using the two distinct points on that line. And from one point, I'm going to count my x value by going. Slope describes the steepness of a line. So when we're looking for the slope of a line, the slope will be made up of our vertical change over our horizontal change, or our y values over my x values. Now the slope is abbreviated with the lowercase m. So when we're looking for a slope, we're going to identify it as m. So I'm going to try to find the slope of this line, or I'm going to find the slope of this line, and I'm going to find it by going from one point to the next, first counting my x values and then my y values. So from one point, and I'm going to start with the bottom point, and I'm going to count over how far the second point is horizontally. So horizontally, it's over 2, so I would put 2 where the x values go. And then I'm going to count how far from there along the y-axis, or the vertical axis, and it goes up 3, so 3 would go on top. So the slope for this line would be 3 over 2, or 3/2. So from one point you count the x, how far the one point is horizontally, and how far from there it's. Slope describes the steepness of a line. So when we're looking for the slope of the line, the slope is made up of our vertical change, or our y values, over our horizontal change, our x values. And the abbreviation for slope is the lowercase m. So m represents slope here. So now when I want to find the slope, and I'm going to find the slope of this line that we have, you're going to use the two distinct points. And in this case, we have the points in the picture, and we're going to count horizontally how far one point is from the other. So I'm looking at the one point, and I'm starting with the bottom. You could use the top point, and I'm going over 2 horizontally to get to that second point. So the horizontal movement, or my horizontal change, or my x's, is 2. So 2 would go in the bottom position of the slope, or the denominator. And then from that, I'm going to count how far it is vertically for my y values. So I count and I go up 3, so my y values, or the vertical change, would be 3. Slope describes the steepness of a line. So when we're looking for the slope of the line, we're going to be looking for the vertical change over the horizontal change, or our y's over our x. And when we talk about how to find it, we're going to be using two distinct points, and we're going to be counting or finding what the horizontal change is and what the vertical change is. Now slope is represented or symboled with a lowercase m. So the lowercase m represents our slope. So I want to find the slope of the line for this picture that is here. And I'm going to represent my slope as m, and m is going to equal the vertical change over the horizontal change. And it doesn't matter which point you choose to start with. I'm choosing the bottom point, and from that bottom point I'm going to count how far off the one point is from the other point horizontally. So when I count, I see that it's 2 spaces away horizontally. Are you kidding me? Slope describes the steepness of a line. The symbol for slope is a lowercase m. So mathematically, we'll be using m to represent slope. So when we're looking for the slope of the line, from one point to the next point, we'll be looking for the vertical change, or our y values, over the horizontal change, or our x values. So when you're given a picture of a line, you're going to find two distinct points, and in this case we are given them, and you're going to count how far off horizontally the one point is to the other, and how far off vertically the one point is from the other. So finding the slope of this line, so it's going to be m equals, and I'm going to find my horizontal change by going from the one point and counting how far horizontally it is from the second point, and I see that it's 2 spaces away, so the horizontal change, or my x values, is 2. And now I'm going to count my vertical change, and I'm going to see that it goes up 3, so the vertical change is 3. So the slope for this line would be 3 over 2, or 3/2. When we're looking for slopes and determining whether a slope is positive, negative, 0, or undefined, you always want to look from left to right. So you always want to look at the graph from left to right. So in a picture, if we're looking from left to right and it slants upward, it's a positive slope. So when we look from left to right, the slope is positive when it goes up. When the slope is going down, the slant is down from left to right, you always want to look the way you read, it is a negative slope. So a slope up is positive, a slope down is negative. Now, when you have a horizontal line, so a horizontal line, we have 0 as our slope. So 0 would be the slope, and a vertical line has an undefined slope. So these are really important. When you're looking at a graph to determine if it's a positive or negative slope, look from left to right. If it's going up, it's positive, down, it's negative. Now, horizontal lines is a slope of 0, and a vertical line is an undefined slope. So this is very important to remember. So I am giving you this little a guide to help you to remember, and this is the Mr. Slope guy, and what it does is it kind of shows you in the face what we're looking at. So a positive slope is that plus for the eye, and the wink is my negative slope, and then the nose here represents my vertical, which is the undefined, so you see that U there, and then my vertical or my horizontal is my zeros or my dimples for the guy. So this is a way of remembering your slope of a line and whether it's positive, negative, undefined, or 0. So when we want to graph a line given a point and a slope, we're going to be doing the reverse. So I'm going to take this point and I'm going to plot it. So we have a point which is 0, 4, and I plot it. So anytime you have a point, you can at least start by plotting the point. Now I have the point plotted, and I need a second point in order to graph the line. So I'm going to use the slope of the line to be able to find the second point. So remember that my slope is my vertical change over my horizontal change. And when we have an integer, in this case I have a -3, I'm going to end up having a -3, but remember, Any integer or whole number you can create a fraction from it by putting it over 1 so that you can get your horizontal change. So your vertical change is the -3 and your horizontal change is 1. Now when you have a negative slope, you always want to move down along the y-axis to represent that it's negative, and you always move to the right for the horizontal change. So in this case, I'm going from where the point was plotted, and I'm going to just count down 3 for my vertical change, and then I'm going to count from that spot over my horizontal change, which is 1, and then I'm going to plot my second point. So to find the line given a point and a slope, first plot the point, then use the slope, and remember it's the vertical change over the horizontal. And if the slope is negative, put the negative with the vertical change and move down, and always move to the right for the horizontal change. Now I can just graph the line, and I have the picture of the line. Pause and try. So again, you're plotting the point, and you're using your slope, and you have your vertical change and your horizontal change because you have a fraction, and because it's positive, your vertical change will go up 2 and your horizontal change will go over 3 to the right, and you plot your point, and now you can graph the line. So when we talk about the slope-intercept form, that is when we have it y equals mx plus b. We have our equation solved for y. Now notice here I have m next to the x value, or the x variable. Well, m again represents the slope. So when you have m, the coefficient of the x is always going to be my slope for the equation, or the slope-intercept form. So the y equals mx plus b, the coefficient of x is my slope, and keep in mind that the slope-intercept, we need the intercept, and it's going to be my y-intercept, and the y-intercept will be the b value. Because remember, my y-intercept is where x equals 0, and if I were to plug in 0 into this formula, you would see that I would have m times 0, and that would go away, and my y value would equal b. So therefore, when it's in slope-intercept form, y equals mx plus b, I'll have my slope, the coefficient of x, and I'll have my intercept, my point, 0, comma b. So you always have a point when you have it in slope-intercept form. Now notice here that we could also have it written in function notation, where we would have f of x equals mx plus b. F of x and y are the same thing. So f of x is function notation, but also means y. So in this equation, y equals 1/2 x minus 3, we're asked to identify my slope and my y-intercept. In this case, it's already in slope-intercept form. So my slope is going to equal the 1/2, or the coefficient of x. My y-intercept, if I plug in 0 for x, is simply going to be a -3. So the order pair for my y-intercept will be 0, comma, -3. Pause and try. So your slope here is a -2, and your intercept is going to be 0, 1. Pause and try. So your slope here is equal to 1/2, and your intercept, be careful here, because the plus or minus, there's no plus or minus, that means that the intercept would be 0, 0. So at the origin. So when you're asked to graph the equation of a line, and it's in slope-intercept form, you need to identify the slope and the intercept. And once you have the slope and the intercept, you plot the intercept, and you use the slope to find the second point. So we have identify your slope, and your slope is 2, and your intercept, or your b value, is a -4 because it's -4. So the intercept point would be 0, -4. So now you're going to plot that point, that intercept, which would be on the y-axis at -4. So we have 0, -4. And then you're going to use your slope to find your second point. Now remember, when you have a slope and it's an integer, you're going to put that integer over 1, so you have that horizontal movement. And because it's positive, we're going to move up 2 from that intercept and over +1 and plot our second point. And now I can graph the line, and this is the graph for y equals 2x minus 4, using the slope and the intercept to graph the line. Pause and try. So again, my intercept is 0, 1. My slope is equal to a -2. I always put the negative with the vertical movement, and my horizontal movement is +3. I plot the point. I go down -2 over +3 to the right and graph my line.